Hi everyone, and welcome back to week 2 of your online learning. I'm Miss Bowden and we're going to be focusing on the Year 6 place value unit of learning. So last week, if you remember, our last session was all to do with rounding, and we're going to carry on that today and tomorrow. Okay, so I'm going to share my screen and we can get started. So same as usual, you need a pencil or a pen and you need a piece of paper to do your working out and write your answers down. Okay, so warm up, day 1, okay? You have got 5 questions again, same as last week, but obviously they're different questions. Give yourself 5 minutes max to have a really good go at these, and then we are going to go through them in quite a lot of detail today, so you know what you're doing for the rest of the week. Okay, so pause the video now, give yourself 5 minutes, have a go, and then join me in a second and we'll go through the answers. Okay, so answers. This is the way that I would have approached the questions, and this is my calculation. So I'm just going to talk you through what I did for each of the questions. So question A, 60 times 3. That was similar to something we had last week, okay, where we needed to know a multiplication fact and then know about multiplying by 10. So if you know that 6 times 3 is 18, we know that 60 times 3 is 180 by the multiplicative value of 10, okay? Question B, so our question was 17,456 minus 4,737. So I've chosen to use the column subtraction method. When I wrote my calculation down, I made sure that because I had a 5-digit number and a 4-digit number, I lined up the place values columns correctly, okay? So the ones had to be in line with each other, which left that 10,000 digit. There's a 10,000 digit in this number, but not in this number, okay? So starting on the right-hand side, we had 6 minus 7, but because if we have 6, we can't subtract 7, okay? Because if I had 6 fingers, tried to chop 7 of them off, I haven't got 7 to cut off, okay? So I need to exchange from the digit to the left. So I've exchanged from the 5, which meant I've carried over 10 to 6, which is why we put the 1 there. So that 5 turns into a 4, okay? So now we've got 16 minus 7, which gives us 9. So now I've got 4 take away 3, gives us 1. 4 minus 7, I couldn't do, because again, 4 take away 7, you'd end up with a negative number, but which we can't do in a regular subtraction. So we need to exchange from the digit to the left. So exchange from the 7 becomes a 6, carry the 1 over. So we've got 14 take away 7, gives us 7. 6 take away 4 gives us 2, and then 1 take away nothing, because we've got nothing in the 10,000s column, gives us 1. So our answer was 12,719. Well done if you got that one correct. C, 9 plus 7 plus 20 plus 28, nope. 9 plus 7 plus 8 is 24. Okay, you could have done that mentally, or you could have written it down. D, 7 times something is 0, okay? To get the answer 0, you times by 0. If you multiply anything by 0, you will always get the answer 0, no matter how big or small the number is. If you multiply by 0, you get the answer 0. So that missing number was 0. And the last one was 76,328 plus 484,313. Okay, so I used column addition for this one, but made sure that I put the bigger number on top. Okay, always really important to remember to do that. So make sure the place value digits were lined up correctly, because we've got a 6-digit and a 5-digit number. Okay, so starting with the 1s, 3 plus 8 is 11, so put the 1s down, carry the 10s. 1 plus 2 plus 1 is 4. 3 plus 3 is 6. 4 plus 6 is 10. So put the 0 down, the 1's digit, carry the 10s. 8 plus 7 plus 1, so 8 plus 7 is 15, add the 1, 16. So put the 1's digit of the 6 down, carry the 1, and then 4 plus 1 is 5. So our answer was 560,641, okay? Give yourself a score out of 5. Well done if you got 5 out of 5 on the first day. If not, you'll be able to improve throughout the week, hopefully, and achieve that 5 out of 5. Okay, so for today's learning, as I said, we're going to be doing rounding. I just want to recap what we were doing last week, because that's going to help you answer the questions that we're going to do today. Okay, so the first thing I want to do is round the following number to the nearest 10,000, 100,000 and 1 million. Okay, so I hope you can remember the rhyme that we learnt last week, but I'm just going to remind you if not. So it's mark your place, look next door, 5 or greater, add 1 more. Numbers before stay the same, numbers behind, zero's their name. Okay, so I'm going to do to the nearest 10,000 first. Just going to get that ready. So mark your place. So because it's the 10,000s, I'm going to circle the 10,000s digit, which is the 4. Mark your place, look next door. 5 or greater, add 1 more. So because it's an 8, we are adding 1 to the circled digit. So that 4 becomes a 5. Numbers before stay the same. So the 4 and the 7 remain the same. Numbers behind, zero's their name. Okay, so the rest of the digits after the circled digit turn into a 0. Okay, so 4,748,309 is approximately 4,750,000 when rounded to the nearest 10,000. Okay, I'll type the next one. Okay, so now I'm looking at rounding to the nearest 100,000. So mark your place. So this time I'm going to circle the 100,000s digit. Look next door. 5 or greater, add 1 more. So because it's a 4, we are not adding 1 more. So we're rounding down. Okay, so when we round down, the circle digit stays the same. Okay, so that 7 is staying the same. Okay, so it's remaining as a 7. Numbers before stay the same as well. Numbers behind, 0 is their name. So the rest of these digits change to a 0. Okay, so rounded to the nearest 100,000, our answer is approximately 4,700,000. Okay, I'm just going to type that one for you. 4,700,000. Okay, and then the last one, so to the nearest 100,000. Sorry, not to the nearest 100,000, to the nearest million. Okay, so this time I'm going to mark your place, circle the millions digit. Oh, oops. Mark your place, look next door. 5 or greater, add 1 more. So 7 is bigger than 5, greater than 5, so we are adding 1 more, so the 4 changes to a 5. Numbers before stay the same, there's nothing there, so nothing's changing or staying the same. Numbers behind, 0 is their name, so the rest of the digits change to a 0. Okay. So to the nearest million, our answer is approximately, that's a better sign, approximately 5 million. Okay. The astronaut is thinking of a whole number, okay, not a decimal number, a whole number. They say that when it is rounded to the nearest 100,000, it is 1,400,000. So I'm just going to underline my important information there. So I'm rounding to the nearest 100,000, and my answer I want to get is 1,400,000. Okay, so my 2 questions are, what is the largest number they could be thinking of? And what is the smallest number they could be thinking of? Where, if they were given that number, you'd round up to 1,400,000 or you'd round down to 1,400,000. Okay? When you get a question like this, it's sometimes easier to visualize it by drawing a number line. Okay, so I've done a quick sketch of the empty number line here. Okay, so we're just going to fill in some information before we get our answer. So the middle line of my number line, okay, you notice I've got 3 lines here. I'm going to put the answer that I want. Okay, so I want to end up with 1,400,000. Okay, because we're rounded to the nearest 100,000, what I want here is 100,000 less than the answer that I would aim to get. Okay, so 100,000 less than 1,400,000 would be 1,300,000. Okay, and as you probably guessed, this line here wants to be 100,000 more than 1,400,000, so 1,500,000. Okay, So as you probably noticed, we're jumping up in 100,000s because that is what we're rounding to. So if you had a question where you needed to round to the nearest 10,000, you would jump up in 10,000s. Okay, so it just depends what you're rounding to. Okay, so the next step you need to take is to find the midpoints between each of those numbers. Okay, so we're going to aim to do the larger one first. Okay, so I'm going to look at this midpoint here first. Okay, so the midpoint is halfway between the numbers. Because we're jumping up in 100,000s, we want to add on half of 100,000 to 1,400,000. So half of 100,000 is 50,000. Excellent. Okay, so if we added 50,000 to 1,400,000, we'd get 1,450,000. Okay. So the same for this, we're adding on 50,000 to 1,300,000. So our midpoint here would be 1,350,000. Okay. So looking at the larger one first, our larger midpoint, 1,450,000. If we rounded that to the nearest 100,000, would it go down to 1,400,000? Let's check. So mark your place, look next door. 5 or greater, add 1 more. Okay, so we've underlined a 5, so that means we would round up to 1,500,000. So we can't use that one as our larger bound, okay, our larger number we could be thinking of. We want to know what 1 less than that number is. Okay, so if we subtracted just one unit, 1 from 1,450,000, we would get 1,449,999. Okay, so that's our larger number it could be. So now let's look at the smallest number. Okay, so look at our midpoint between 1,300,000 and 1,400,000. So let's see whether that would round up to 1,400,000. Okay, so mark your place for the 100,000s digit, look next door. 5 or greater, add 1 more. Excellent. Okay, so 5 would round up, so the 3 would round up to 400,000. So that is our smallest number it could be, okay, because it's our midpoint. If we subtracted 1 from 1,350,000, we would get 1,349,000, and that would round down to 1,300,000. So this is our smallest possible number it could be. Okay, so then if we rounded any number in between these two numbers, all of these numbers would round up to 1,400,000, and these numbers would round down to 1,400,000 to the nearest 100,000. Okay. So there are some digits missing in these numbers. They all round to 240,000 when rounded to the nearest 10,000. Complete the missing digits. Okay, so I'm just going to write that number for us because we got it in words, but I want it in digits. So 240,000. 40,000. Well done if you got that before me. So that is the number we want to round to. Okay. So this first one, we've got 2 in the 100,000s, we've got a 4 in the 10,000s, but we haven't got our thousands digit. Okay. So if we want to round to 240,000, do you think we have rounded up, or do you think we have had to round down? Excellent. We're going to have to round down, because if this number was 5 or more, then the 10,000s digit would have increased to a 5, so we would have had 250,000. So this digit here would have to be 4 or less, okay, when rounded to the nearest 10,000. So it could be 0, it could be 0, 1, 2, 3, or 4. I'm going to put a 4 in there, just so as it's full, but it could have been any of those possibilities. Okay, so for the next one, we've got a 2 in the 100,000s, lovely. We haven't got our 10,000s digit, which we're rounding to the 10,000s. We've been given the thousands digit, the 7, and we've got 356 at the end, okay? So if the thousands digit is, so if we were doing mark your place, sorry, I probably should have done that for the first one. Mark your place, we're marking the 10,000s digit, look next door. The thousands, okay? 5 or greater, add 1 more. So because it's 5 or greater, we would be rounding up. So we would be adding 1 to this number, okay? If we've added 1, we would get the answer 4, because that's the answer we're aiming for. So to work backwards, what's the opposite of adding 1? taking away 1, okay? So 4 take away 1 would give us 3. So the answer for this one, there's not multiple options, okay? It has to be a 3, okay? Because if it was a 4 and we rounded up, it would change to a 5. If it was a 2 and we rounded up, it would change to a 3. So we need the answer 3 in there, okay? So for this last one, let's think about mark your place again. Mark your place. So rounding to the nearest 10,000, we're going to circle our 10,000s digit. So 200,000s, 3 10,000s, and then we need the thousands digit, okay? So because we want to end up with the 4 in the 10,000s column in the answer, what's happened to the 3? Have we rounded up or has it stayed the same and rounded down? Excellent, we rounded up, so that means we're going to have to add 1 to it, so we want to round up. So what would the thousands digit have to be for us to round up? Could it be a 0? No, because that means we would have to round down and the 3 would stay the same. So it'd have to be 5 or more. Okay, so you could have the answer in there of 5, 6, 7, 8, or 9. Okay, I'm going to put 9 in there. That's my answer. Okay, so that is just shown a bit there. Those are your possible answers there. Not sure why 9's missing from there, but you could have 9 there. Okay, well done if you got those before me. Right, so now on to your task. Okay, so you've got 2 tasks that are very similar to what we've just done. So for the first one, it says write 5 numbers that round to the given numbers when rounded to the nearest 100,000. So think about marking the place and thinking about what your lowest possible answer it could be and biggest possible answer it could be. So you could have any number in between those. Okay, so you've got 3 different ones to do there. And then for the second task, okay, so it says, the first one says, these numbers have missing digits. Each number rounds to 370,000 when rounded to the nearest 10,000. Give all the possible answers. Very similar to the question we've just done, okay? So flick back to that if you want another hint. And the last one says, James says, my number is 2,450 when rounded to the nearest 10. Sarah says, my number is 3,000 when rounded to the nearest 1,000. What is the smallest possible difference between the 2 numbers? Now that one's a trickier one, okay? We're going to go through that one in the most detail, but see if you can have a go at working that out. I'll give you a hint. You need to work out the smallest possible and the biggest possible numbers it could have been before you rounded to then work out the difference, okay? Good luck. So pause the video here, have a go at those questions, and then unpause me and we'll go through the answers. Okay, so for the answers, first question. So for the right 5 numbers that round to the given numbers when rounded to the nearest 100,000, you needed to make sure you looked at the 100,000s digit in each of these numbers. I know C was trickier, so I'll talk through that in a second. So for the first one, 1,200,000, the smallest possible number it could have been was 1,150,000 because so mark your place, look next door, 5 or greater, add 1 more, we would round up to the 200,000 there, okay? And then the largest possible number it could have been, so mark your place, look next door, 5 or greater, add more. Because it's not 5 or greater, we're not rounding up to the 300,000, so we would round down, so the 2 stays the same at 1,200,000. So any number in between these 2 numbers, so in the middle, bigger than 1,150,000 and smaller than 1,249,999 would have been absolutely fine. So for the next one, so the 7 was your 100,000s digit. The smallest number you could have had was 650,000, and the biggest number you could have had was 749,999. Okay, so any number in between those 2 numbers would have been correct. Okay, so for the last one, because we had 0 as our answer, we didn't have a 100,000s digit to use. Okay, so what I thought about here was if I had a number line, okay, and I had a 0 here and 100,000 here, because that is the first 100,000 if we were counting in 100,000s, okay? I wanted to think about what number would be in the middle in between these 2 numbers as our midpoint for if you're in the middle, the numbers on the right would round up to 100,000 and the numbers on the left would round down to 0. Okay, rounding to the nearest 100,000. So what is the middle number between those? It's 50,000. Okay. But if we rounded 50,000 to the nearest 100,000, so if we marked our place and look next door, the 5 is 5 or greater, add 1 more, so we would round that up to 100,000. So we wanted 1 less than 50,000, which would be 49,999. So any number between 0 and 49,999 would have been fine. Okay. So for question 2, we had these numbers have missing digits. Each number rounds to 370,000 when rounded to the nearest 10,000. Give all the possible answers. Okay, so for the first one, the thousands digit that was missing could have been any number bigger than 5. So we'd round that 10,000s digit up to 70,000. And the second one, because we were missing the 10,000s digit and the thousands digit was a 3, we know we needed to round down. So when we round down, the 10,000s digit would stay the same. Okay, so the missing number was 7. Okay, it only could be 7. And the last one, where the thousands digit was missing, okay, so where we mark our place, because we've got 7 there already, we know we wanted to round down to keep that 7 the same, so it could have been any number that was less than 4. Okay, so you could have had 0, 1, 2, 3, or 4 in that missing number. Okay, so for B, the trickier question, the first thing you wanted to do is work out the smallest and largest possible answers for each of the statements that James and Sarah have made. Okay, so my number is 2,450 when rounded to the nearest 10. Okay, so mark our place. We want to look at the tens. Okay, so the smallest number is going to obviously be less than 2,450. Okay, and so the tens digit will go down to 1 less. So we would have 2,440. So we need to think about what that ones digit, the smallest possible option it could be to still round up, which would be 5. Okay, because if it was 4, we would round down. So the 4 would stay the same. So 5 would round up to make it into the 50. Okay, so the biggest possible number it could be would be 2,450. So because we've already got the 5 in there, we want to round down to it this time. Okay, so the ones digit, the biggest possible option it could be would be a 4. So 2,454. Okay, so for the 3,000, it says my number is 3,000 when rounded to the nearest 1,000. Okay, so the digit we're looking at here is the thousands digit. Okay, so we want the largest possible answer it could be and the smallest again. Okay, so the smallest possible option it could be, so we'd decrease the digit by 1, so we'd have 2 here. Okay, and then the next digit that look next door, we would need to round up to 3,000, so the smallest possible option it could be would be a 5, and then the rest of the digits would be a 0. So our smallest option it could be would be 2,500, and our biggest option it could be would be 3,499. Okay. Then the last bit of the question says, what is the smallest possible difference between the two numbers? Okay, so these are our smallest and biggest possible answers it could be. So to work out the smallest possible difference between the two numbers, we need to use the biggest option it could be here, okay, which is 2,454, and we need to use the smallest option it could be for the second number. Okay, so we want a difference. Okay, what does the word difference mean? I hope some of you worked that one out. So difference would be, you would be working out a subtraction calculation. Okay, so you could have written a subtraction, or if you can work this out in your head, excellent. Okay, so the difference between 2,454 and 2,500 would have been 46. Okay, because you would have to add on, so adding on 6 would take you to 2,460, and then adding on the extra 40 would take you to 2,500. Well done if you got that last one, it was really tricky. Okay, Lovely. So that is everything for today. Okay, I'm going to stop sharing my screen. Tomorrow we're going to do a few more tricky problems that involve rounding, okay, not just fluency questions. So come back tomorrow for some more practice on rounding. Okay, bye.